Okay, Assalamualaikum and hello everyone. So now we will continue with tutorial question chapter 11 number 4C. A radioactive source was prepared at 12 hours. Okay, maksudnya dia is prepared at pukul 12. And the activity of the source at 14 and 16 hours were 2.39 times 10 to 11 becquerel and also 4.06 times 10 to the power of 9 becquerel respectively. What is the initial activity? So dia minta kita cari initial activity. So we know if kita nak cari initial activity, we can use this formula. Okay, equation of activity, which is activity equals to initial activity exponent negative decay constant times the time taken. So we can use this formula. Alright. Unfortunately, we can find the time taken. We can find, and we already know the activity at 14 hours and 16 hours, but we do not know the decay constant. Nak tak nak, kita kena cari dulu kita punya decay constant, dan only baru kita boleh masuk dalam this formula. So kita kan ada 2 hours. Okay, we will have 2 hours, which is 14 hours and 16 hours. So for the 14 hours ini, Mus akan jadikan dia punya activity as A1. And then untuk 16 hours ini, Mus akan jadikan dia punya activity as A2. So meaning kita dah ada A1, kita cuma nak cari initial activity, but we do not have dia punya decay constant. Sebab time taken dia pun kita boleh cari. So you can either use this equation or another one, activity 2. Alright, cuma bezanya sama juga. Kita boleh cari time taken dia, tetapi kita tak ada dia punya decay constant. So what about the time? Okay, what about the time? Okay, untuk time dia, kita akan cakap at 12 hours, benda radioaktif baru tengah prepare. So bila dia tengah prepare, dia punya time is 0. And then at 14 hours, time dia berapa dah? Dah berapa dah daripada initial dia? So dah beza dia sebanyak 2 jam. So the difference is 2 hours already. So bila dah beza sebanyak 2 jam, kita boleh cari the time taken. So 2 jam darab 60 minit darab 60 saat, awak akan dapat 7200 second. And then at 16 hours, so daripada initial time tu sampailah 16 hours, beza dia adalah sebanyak 4 jam, 4 hours. Jadi letak je 4 times 60 times 60, awak akan dapat 14,400 second. Alright, so this is how you find the time taken. Okay, so macam Miss cakap, tak kisah you nak guna the equation for activity 1 ke, equation activity 2 ke, but you already know the time taken, and you already know your activity at 14 hours and activity at 16 hours. Untuk cari initial activity, tetapi you tak tahu decay constant dia. So macam mana kita nak cari dia punya decay constant? Okay, mari kita buat. So kita tahu rate of decay bersamaan dengan negative decay constant darab dengan number of nuclei. And kita juga tahu rate of decay dia sama dengan activity. Therefore, kalau kita samakan equation number 1 dengan equation number 2, kita tahu activity bersamaan dengan rate of decay darab dengan number of nuclei. Alright, so sekarang Miss dah tahu dah Miss punya activity. So contohnya activity for 14 hours, which is Miss label sebagai A1, adalah rate decay constant darab dengan number of nuclei 1, which is equals to 2.39 times 10 to the power of 11 becquerel. So kalau activity 2 equals to decay constant darab dengan N2, which is equal to 4.06 times 10 to the power of 9 becquerel. So from here, actually Miss boleh buat apa tau? Miss boleh buat ratio. Miss boleh buat ratio of the activity. From here, Miss boleh buat ratio of the activity. So ratio dia akan jadi A1 over A2 equals to lambda N1 over N2, which is equals to 2.39 times 10 to the power of 11 becquerel bahagi dengan 4.06 times 10 to the power of 9 becquerel. And we know the decay constant is the same. Kenapa? Kenapa decay constant dia adalah sama? Decay constant dia adalah sama disebabkan dia adalah radioaktif yang sama. Sudah dapat dah dia punya ratio of the activity. Okey, tapi macam mana you nak cari decay constant? Tak apa. Kita tengok, kita boleh guna number of nuclei punya equation. Kita boleh guna nuclei remaining punya equation. So, for nuclei remaining punya equation, N, kita tahu N equals to N naught exponent negative decay constant darab dengan time. So, sekarang kita akan buat juga untuk 14 hours dan juga 16 hours. So, N1 equals to N0 exponent negative decay constant darab dengan time. So, kita tak tahu number of nuclei of 4, remaining 4, activity 14 hours. Initial nuclei number pun kita tak tahu, it's okay. Tetapi kita tahu the time taken. So, the time is 7,200 second for activity of 14 hours, at 14 hours, which is yang Miss label sebagai A1 tadi. Manakala kalau untuk N2, the time taken is at 14,400 second. 14,400 second. So from here kita buat ratio lagi. Kita buat ratio. So from here kita buat ratio. So N1 over N2 equals to N0 exponent negatif decay constant darab dengan 7,200 bahagi dengan N0 exponent negatif decay constant dengan 14,400 second. So N0 dengan N0 ni kita boleh potong. Dan ini adalah konsep indices. Okay, kena ingat balik indices yang awak pernah belajar waktu zaman sekolah. So exponent akan jadi negatif 7,200 decay constant tolak dengan negatif 14,400 lambda. So which is equals to exponent 7,200 lambda. So N1 over N2 awak adalah 7,200 lambda. So sekarang from here, yang mana Miss highlight dengan buat kotak kuning ni, ini adalah penting. Okay, this is important. So we know from these two adalah, awak tahu awak punya A1 over A2 equals to N1 over N2 adalah, awak bahagikan dia 2.39, it is 2.39 times 10 to the power of 11 becquerel bahagi dengan 4.06 times 10 to the power of 9. And then dekat sini awak tahu N1 over N2 adalah exponent 7,200 decay constant. So this is your first equation and this is your second equation. So kita substitute equation 2, substitute equation 2 into 1. Kita nak buat, kita nak cari kita punya decay constant. Okay, sorry ya, sebab ni banyak sangat matematik, ni semua rimas juga. So how do we get rid of exponent? Kita ln both side. So ln is 7,200 decay constant equals to ln, kita lupa ln dah, ln 2.39 times 10 to the power of 11 bahagi dengan 4.06 times 10 to the power of 9. Okay. Okay, so when you ln both side, you akan dapat lah, so misalkan continue dekat sini, so you will get 7,200 lambda, which is equal to 4.075. So your decay constant actually is 5.66 times 10 to the power of negative 4 decay per second. No decay, per second only. Dia adalah per second. So now you already have your decay constant. Kita punya aim apa? Kita punya aim, kita nak cari dia punya initial activity. So it's up to you. You nak pakai bila dia punya time at 14 hours, activity at 14 hours ataupun at 16 hours. Kalau macam Miss pakainya at 14 hours. So kita tahu A1 equals to A0 exponent negatif decay constant darab dengan time taken. Dan kita tahu activity at 14 hours adalah 2.39 times 10 to power of 11. Okay, dia adalah 2.39 times 10 to power of 11. Kita nak cari initial activity and then dia punya decay constant. So decay constant yang kita cari tu 5.66 times 10 to power of negative 4. Dan untuk activity at 14 hours, the time taken is 7,200 seconds. Okay, so from here, you can find already your activity, initial activity, which is you will get your final answer 1.41 times 10 to power of 13 becquerel. Okay, so Miss tak tunjuk dah mathematic for this part. Mathematic for this part, you can just press the calculator and I think you will get it. Okay, so that's also, and this is the final answer. So that's all for 4C, and it's a lot of mathematic. Okay, dia banyak sangat mathematic and the concept is quite easy to understand, tapi you all kena try fahamkan dia lagi. Okay, that is for